In this lesson, we're looking at factorising trinomials. So we'll start off by identifying trinomials, which are simply a quadratic form which has three terms in the form ax squared plus bx plus c. And then we'll look at how we factorise them using decomposition method. So there'll be two steps to this, A, C, and B table. Pretty much, if you know your multiplication tables, this will be fine. And then we'll look at factorising by grouping, which is just a simple process to follow. Okay, so a trinomial is a quadratic in the form ax squared plus bx plus c, where a is the coefficient of the x squared term, b is the coefficient of the linear term, and then c is simply the constant. Now, when we go back to our order, after we've taken out common factors, if they exist, and we look to apply our dots or perfect square, then the next step is to check to see if it's a trinomial. And we'll be using the decomposition method that we'll be going through now. Okay, so as we said before, to use decomposition method, it needs to be in the form ax squared plus bx plus c. Now I'll go through an example it's the easiest way to learn this method. So if we look at factorising x squared plus 5x plus 6. Now the first few things we notice is there's no common factors and it doesn't fit a dots or perfect square. So this 6 is not a square number. So step one is we draw our A, C, and B table. So just over to the side, A, C, and B. So AC means A times C. So if we write out that A is equal to 1 because it's 1x squared, B is equal to 5 because it's 5x, and C is equal to 6 because C is always just a constant value. And AC is equal to 6 and B is equal to 5. So what we're looking for here is two numbers that multiply to equal 6 and add to equal 5. So the numbers that would work in this scenario are 3 and 2. So 3 times 2 to get 6, and 3 plus 2 gives us 5. Ultimately what we're doing here is we're breaking that middle term, that 5x, into 3 and 2 in order to be able to factorise. So that's our next step. We now have x squared plus 3x plus 2x, and our final term was 6. So we've broken that 5 into 3 and 2. Now we're going through a process called factorising by grouping. So we look for the common factor in the first two terms, and then we look for a common factor in the second two terms. So in the first two terms, we have a common factor of x, and we're left with x plus 3. In the second bracket, we have a common factor of 2, and we're left with x plus 3. Now you know you've done this process correctly if you have the same brackets for each of these. Because in this final step, the bracket becomes a common factor. So we've got a common bracket of x plus 3. That means remaining is x plus 2. So there we have our fully factorised quadratic. Alright, so we'll do a couple of extra examples. Yeah, in this second example, we're looking at factorising 2x squared plus 7x plus 6. So again, there's no common factors. And we cannot use our perfect square or difference of perfect squares methods because they don't fit that pattern. And we can see that pretty clearly, that 6 is not a square number. Alright, so A will be equal to 2, B will be equal to 7, and C will be equal to 6. So now we've got our A, C, and B. A times C is 12, and B is 7. So what numbers multiply to equal 12 and add to equal 7? So 12, 4 times 3, and 4 plus 3. That fits in both these scenarios. So now we can rewrite this this quadratic with 7 as 4 and 3. So 2x squared plus 4x plus 3x plus 6. Now we factorise by grouping. So the common factors in the first bracket are 2x, we're left with x plus 2. And in the second bracket, the common factor is 3, and again we're left with x plus 2. We let x plus 2 be our common factor, and we're left with 2x plus 3. So there again we have a fully factorized quadratic. Now we're going to look at factorizing 10x squared, take 11x, take 6. Now we can see it's a trinomial. There's no common factors. And the only difference is that now we've got negatives for the linear and constant terms. So if we write down what we've got a is equal to 10, b is equal to negative 11, and c is equal to negative 6. So when we look at our AC and B, AC is negative 60 and B is negative 11. So as this AC value is negative, that means one of the two values needs to be negative. And since B is negative, it means the larger value is going to be negative. So for 60, we can use 15 times 4. But it won't just be 15, it'll be negative 15. So negative 15 times 4, and that gives us negative 60. Now negative 15 plus 4 gives us a negative 11 that we're looking for. So now we can break a trinomial into its 4 terms. So we have 10x squared, take 15x, plus 4x, take 6. Now this is a negative 15 in both, and a positive 4 in both. So now we do our factorizing by grouping. So the common factors here are 5 and x, so 5x, and we're left with 2x, take 3. The common factors in the second one are simply 2, and we're left with 2x, take 3. So these two brackets are the same, and we get 2x, take 3 as a common bracket, and 5x plus 2 remains. So there we have our factorized trinomial. Okay, in this last example, we're looking at factorizing 50x squared, take 95x plus 35. Now that's a daunting task, but remember there's always a first step, and the first step in this case is we need to try and take out a common factor. We can see that they're all divisible by 5. So if we take out the common factor 5, we're left with 10x squared minus 19x plus 7. Now, factorizing 10x squared minus 19x plus 7 was going to be a little bit easier. So consider 10x squared, take 19x plus 7. When we look at AC and B here, where A is 10, B is negative 19, and C is 7, AC is 70, and B is negative 19. Now 70 can be 14 times 5, so 14 times 5 and 14 plus 5. Now the problem here is that 14 times 5 gives us the right answer, but 14 plus 5 gives us positive 19 instead of negative. So that means both of these two, 14 and 5, need to be negative. And so now that works. 14 times 5 is 70, or negative 14 times negative 5 is 70. Negative 14 plus negative 5 is negative 19. And now we can look at using our factorized by grouping technique. So we have our 10x squared, take 14x, take 5x plus 7. Now, the common factor here is 2x, so 2x, and we're left with 5x, take 7. And the second one, we just have to take out negative 1 as a common factor. So negative 1, and we're left with 5x, take 7. So 5x, take 7 is a common bracket, and we're left with 2x, take 1. Now recall that that was just for 10x squared, take 19x, take 7. So 50 x squared take 95x plus 35 will be 5. 5x takes 7, 2x take 1. And that's because we took that common factor out right at the start. And there we have it, it's fully factorized. So that concludes our lesson on factorizing trinomials. You'll need to do a bit of practice on these. They take a little bit of time to get used to. Once you get down pat that process, it's relatively straightforward.